Let's look at control methods for a heat pump. There is more than one way to control a heat pump, but we will cover the best practice methods to ensure good levels of efficiency. Key points that we will cover are required heat demand for the building, weather compensation and heat curves, setback temperatures instead of off periods, room influence, and hot water control. An important aspect when designing a heat pump system is conducting a thorough room-by-room heat loss calculation for the entire property. Accurately knowing what heat demand a property has is crucial when it comes to efficient control. The primary factor influencing a building's heat demand is the weather, which constantly changes. Consequently, the heating requirements of a building fluctuate as well. It's logical that we should have controls to automatically adjust to these changing heat demands. This highlights the benefit of weather compensating controls, as adjusting the heat delivered to meet the heat demand helps reduce unnecessary energy usage and provide a more stable temperature within the home. Weather compensation controls adopt a proactive approach to heating buildings, continually adjusting the heat source output dependent upon the current weather conditions, while still maintaining a consistent room temperature. Non-weather compensating controls, however, reactively respond to temperature fluctuations rather than adjusting to meet the heat demand. This leads them to commonly over and undershoot the requested temperature within a room or building. These are commonly referred to as on-off style controls. A typical weather compensation control works by having a sensor constantly monitoring outdoor conditions. Positioning this sensor on an outside north or northwesterly facing wall promotes more accurate readings. This is because it will not be exposed to direct sunlight. Some other weather compensation controls take live readings from the Met Office data website. This sensor and/or web data communicate the outdoor temperature to the internal controller, which then adjusts the heat supplied by reducing or increasing the flow outlet temperature from the heat pump. Weather compensation controls require the installer to select a curve. This selected curve is what determines the radiator temperature in relation to the outdoor temperature. The curve selected is determined by the design of the heating system. Quite simply, this will result in warmer radiators on colder days and cooler radiators on warmer days. The room temperature, however, will remain as selected, providing a very comfortable temperature environment. Heat pumps are designed to be a continual heating source, maintaining the heat within a building. A good control will allow programming of desired comfort temperature and something known as setback temperature. It is more efficient to use setback temperatures in place of the off periods when controlling a heat pump. Common temperatures used are 21 degrees C for comfort and 18 degrees C for setback periods. The best heat pump controls also incorporate a function called room influence, which accounts for the actual building temperature as well as the outdoor temperature, optimising the weather curve. This enables the low and slow heating method. This doesn't work the heat pump compressor as hard and as such uses less energy. The heat pump controller controls this by using indoor and outdoor temperature readings to automatically calculate the optimum amount of heat to produce and supply to the radiators. Advanced controls also learn over a period how long the heat-up operation takes for the property in which they are installed. This allows even more precise control, reducing unnecessary energy usage. Moving on to hot water control, heat pumps will require a cylinder for hot water production. When there is a simultaneous demand for both hot water and central heating, the heat pump controls will always prioritise the hot water. The central heating will be suspended until the hot water cylinder reaches the desired temperature. This highlights the importance for the correct cylinder size to avoid excessive hot water reheat periods. The cylinder must be specifically designed for use with a heat pump. They will feature a larger surface area heating coil compared to standard cylinders. This design enables fast and efficient reheating of water at lower flow temperatures. We have covered a lot of content to provide a high-level overview of heat pump controls. Controls play a crucial role in a heat pump's performance and efficiency. The main points that we have covered are: a full heat loss calculation for the property is required. Weather compensation controls are essential. Controls that also feature room influence and learn the building's characteristics further increase comfort and efficiency. And correctly sized heat pump cylinders are essential.